Welcome back. In this video, we will discuss the normal approximation of binomial probability distribution. Let us take a look at figure 2.9 and figure 2.10. I have one question for you. What do you see from both figures? Yes, you may see that the shape of the probability distribution histogram in figure 2.9 is skewed to the right, and in figure 2.10 the shape is approximately normal. What else do you observe? You observe that the probability of success P for both figures are equal. However, the number of trials are different. In this setting, if your random variable x is binomial distributed with two parameters n and p, it can be approximated to normal random variable with mean mu equal to np and variance equal to npq at three conditions. What are the conditions? The first one, n should be at least 30, np at least 5, and nq at least 5. Let us take a look at example of this type of approximation. Recall that this is a table of probability distribution where the first column is the list of your possible outcomes 0 until n. The second column is the probability of associated outcome. For example, the value of 0.02953 is the probability of getting exactly 5. The third column is the cumulative probability distribution. How to read the third column? It is very simple. Let me show you. The blue cell is obtained from the summation of all these 6 purple cells, or it is equal to the summation of probability x equal to 0 until probability x equal to 5. So this is an example of cumulative distribution. Now let us take a look at our example. Before that, let us fill in this table. What is our n? Yes, your n is equal to 50. What is your p? Yes, p is 0.2. What do you know about q? Q is 1 minus p. And the multiplication between n, I just choose the cell, is given by 10. And the multiplication between n and q is given by 40. So let us check the three conditions. The first condition is n at least 30. In our case, n is already more than 30. The two conditions, multiplication should be at least 5. Okay, should be at least 5. So both of these multiplications are greater than 5. So let us take a look at one example. Now, if I am interested to calculate the probability of x less than 6, I know that it is equal to probability of x equal to 0 plus x equal to 1 until x equal to 5. And this summation is equal to the blue cell. 0, x equal to 0, x equal to 1, x equal to 2 until x equal to 5. So we sum all these purple cells and we will get the blue cells. This is probability of x less than 6 and I am using binomial probability distribution function to find the probability of interest. Now, since the conditions are met, I want to use the normal probability distribution function to solve for the same probability of interest. However, before we continue, we have to consider our continuous correction factor or CC factor. There are several types of CC factor. I just highlight our case. In this problem, we have x less than 6. So it is approximated to your random variable x less than 6. So you will have 6 minus 0.5, which is 5.5. So let us take a look here, the computation. So originally your random variable is a binomial random variable x, and now since the conditions are met, you want to solve it using normal probability distribution function. Before you can solve using normal probability distribution function, you have to consider the CC factor, and this is our case. That is the reason I subtract 6 with 0.5. I will get 5.5 here. Since we are now at normal random variable, and how do we solve this kind of probability problem? We have to transform from x random variable to standard normal random variable. How do we transform? Is simply minus by the mean. We know that the mean is NP and variance NPQ. So the mean is 10, and this is divided by the standard deviation. So you have square root of NPQ. X minus mu, your mean, divided by standard deviation. Standard deviation is given by square root of NPQ. I simplify my right hand side, so I will get 1.59. So you can use your calculator to check for the computation. This is area to the left of our standard normal table. I suggest you to draw the area of interest or to sketch the area of your interest. So it is given by, to obtain the area of interest, it is given by 0.5 minus by the area between negative 1.59 and 0. By looking at the standard normal table, this area is equal to 0.4441. Therefore, the area of your interest is simply 0.5 minus the area obtained from your table of standard normal, which is given by 0.0559. Approximately 0.06. Okay, now by using the normal probability distribution function for the event of interest, probability x less than 6, you will get 0.06, around 6%. And if you calculate the same probability of interest using binomial probability distribution function, you will get around 0.05 or 5%. So this is an example of binomial random variable that can be approximated to normal random variable, and you solve it using normal probability distribution function. So hopefully by this video it helps you to understand normal probability distribution function. Do not forget the conditions and then the correction factors. Please shade your area of interest to make it clearer for you, and you should be able to read standard normal table in order for you to calculate your probability values. With that, I end the video. Can you please try out tutorial 2 questions so that you have a good understanding about this type of approximation. Thank you.